Assalamualaikum and good day to you all. I'm Omar from JTK FTK. Basically, we're going to look into the basic law topic, which is Y delta transformation. So last time we already looked into the series resistor and parallel resistor in order to find the voltage and current in the electrical circuit. Okay. Okay. Previously, we already looked into the series and parallel resistor. But in certain case, if we face the circuit that neither can be solved using series or parallel, then we can do the Y delta transformation. Okay, so for example, this circuit. Okay, this circuit. So this circuit you cannot solve by using a simple series and parallel resistor circuit. Okay, so that's why Y delta transformations exist. Okay, so you have to do either from delta to Y, or you can do from Y to delta, depending on what you want to solve. Okay, so now let's say we look into a delta to Y transformation. So from the delta circuit, then change to Y circuit. Okay, let's say like this. Let me copy this one first. Okay. Okay. Let's say we want to convert from Y circuit to delta circuit. Okay, that's means from R1, R2, R3 into the RA, RB, and RC. So, what is the equation? Okay, so we can do like this. Okay, from Y to delta. If you want to solve, if you want to get the RA value, okay, RA value, that's mean RA is opposite to this one, R1. Okay, so in order to determine the RA, we just do this. Oops. Okay. Okay, so for the RA, sorry. So for the RA, okay, so for the RA is equals to okay, divide by R1. Okay, for RA is the opposite one is R1. Okay, so in order to get the RA, this one R1. Okay, RA is equals to R 1 times R2 times R2 R3 plus R3 R1 over R1. Okay, for RA is R1. Let's say for RB. So RB, the division is R2. So that means the bottom side of the equation is R2. The top one same for all equations. So R1 R2 plus R2 R3 plus R3 R4. Okay, no, sorry, R3 R1. Okay, so for the RC resistor is R3. Okay, R3. So the division, the bottom side of the equation is R3. The top one is same to all equations. So R1 R2 plus R2 R3 plus R3 R1. Okay, so this is the equation to convert from Y circuit into the delta circuit. Okay, how to do the Y to delta transformation. Okay. After this, we're going to do the example. Okay. Now let's look into the delta to Y transformation. Okay, let's say we have this. First, let's put this. Okay, so now for the delta to Y, okay, from delta circuit into the Y circuit. Okay, so for that, let's say we want to find the R1, R2, and R3. Okay, for the R1 is equals to RB times RC. Okay, so for R1, the resistor that we have to look is the top one is RB times RC. Okay, RB times RC divided by RA plus RB plus RC. So the bottom one all same, all equations same. Okay, but the top one is different depending on whether R1, R2 or R3. Okay, so for the R2, look here, the multiplication between RA and RC. So for R2 is RA times RC divided by RA plus RB plus RC. Okay, so all same for the bottom one. Okay, for the R3, R3 is here, RA times RB. Okay, so for the R3 is RA times RB divided by R1, RA plus RB plus RC. Okay, so this is the equation to transform from delta circuit into the Y circuit. Okay, you have to remember all these three. Not remember, but you need to understand how to get this equation, how to calculate the value from Y to delta and delta to Y. Okay, let's do the exercise for Y delta transformation. Okay, let's say if you got this circuit, okay, so for this circuit, we need to find the current in the circuit. But first, in order to find the current, you need to come up with the end circuit like this. Okay, you have the supply, and then you need to have the equivalent resistor. Okay, so this equivalent resistor, you need to simplify all this resistor, but you cannot just use series and parallel equation to solve the circuit, because it got this is delta, and then if we look here, 24 ohms, 20 ohms, and 30 ohm resistor is a Y circuit. So first you need to solve this circuit using Y delta or delta to Y transformation. So then you can get the final equivalent resistor for this circuit. Alright, so let's do it. Okay, so first let's try to change to convert this resistor. Okay, let me delete this one first. Okay, let's try to convert this. Sorry, this one. Okay, change to from delta to Y resistor. Okay, so that's mean we expect it to become this circuit. Okay, we have this. Okay, and then this one. Okay, so we have RA, RB, RC. Okay, so you need to remember the equation. So in order to get the RA value, okay, RA is so this one is delta to Y. So let's have a look into this. Okay, so from delta to Y, So for the R3, for example, R3, for example, you need to multiply with side by side resistor. Okay, so this means for the RA is 24 times 10. Okay, for the RA resistor is, it should be okay, 24 ohms times with 10 resistor, 10 ohm resistor, divided by 24 plus 20 plus 10. Okay, so you get the answer. Yeah. Same with RB. Okay, for RB in here, 24 times with 20 divided by 24 plus 20 plus 10. Okay, equals to, and then for the RC is 20 times 10. Okay, 20 times 10 divided by 24 plus 20 plus 10. Okay, okay, use the calculator, you will get the value. Okay, okay, 24 times 10 is equal to 240 divided by uh, 54. Okay, 54 divided by 54, 24 plus 20 plus 10, 54. So you will get RA is 4.44. Okay, on the other hand, for RB is 24 times 20 divided by 54, you get 8.89. Okay, 8.89 ohm. And for the RC is 200 divided by the 54, you will get 3.70. Okay, 3.70 ohm. Okay, now we already convert this circuit into the Y circuit, so you need to redraw back to make sure that you can clearly see how the circuit arranged. Okay, so let's try to do the redraw. Okay, we have 13 ohm, and then we're going to have 4 ohms, and then we have, this is 4.44 ohms. Okay, RA, and then RB is 8.89, and then we have RC, which is 3.7 ohms, and then connected with a resistor 30 ohm, and then for another resistor 50 ohm. Okay, 50 ohm, and then after that it's connected together and back to the supply. Okay, and the supply is 240 volt DC. Okay, so now you can solve this. Okay, using a simple series and parallel resistor equation. Okay, now let's simplify. Okay, this one, series resistor, you can combine together. Okay, same with 3.7 and 50, also you can combine together. Okay, now I can same with 13 and 4.4, make it together. So redraw again, 240. So you get one resistor here, and then you have one resistor here, and then another resistor like this. Okay, so 13, and this one is 13 plus 4.4 is become 17.44. Okay, and for this one 30 plus 8.89, so it will be 38.89. Okay, and the outer side is 53.7 ohm. Okay, so now for this one you can you can solve using the parallel circuit. Okay. Okay, let's open another one. Okay, just copy this. Oops. Okay, let's see. Let's put it here. Okay. Okay, 53.7. Let's write it down. 53.7. Okay, so from this you have to combine the parallel circuit. Okay, so let's say this one is R1. So R1 is equals to um, 38.89 times with 53.7 divided by 38.89 plus 53.7. So this one you will get, let's do it, 38.89 times with 53.7, okay, and then divided by 38.89 plus 53.7. So you get 3.63 ohm, okay, for the resistor. So you can draw again, simplify your circuit again. That's the better way to solve it. So you will have this resistor 17.44 and 3.63. So this one you can, so this two resistor is connected in series, so you just uh, uh, sum it. Okay, so the final circuit will be like this. You will have supply, and then you will have this resistor R equivalent. R equivalent is 17.44 plus with 3.63, which is 17.4. So you will get about 21.1. Okay, so 21.1 ohm resistor, equivalent resistor. So then you can determine the current that passing through this equivalent resistor, which is for the current is I equals to V over R equivalent, uh, which and the voltage is 240, and the equivalent resistor is 21.1 ohms, which is 240 divided by answer, you get 11.4. Okay, so the current is 11.4 amp. Okay, okay, so this is the solution for uh, this circuit. Sorry, for this circuit. Okay, okay, so hopefully you can understand how to do the uh, Y to delta transformation, and also delta to Y transformation. Okay, as well as series and parallel circuit calculation. Okay, so that's it for this time. Thank you very much. Okay, so that's it for this time, and see you again.